Okay, so let me begin with our separation technique webinar. Okay, so what is a correct statement? Okay, that gives the correct difference between simple distillation and fractional distillation. Okay, so option A, simple distillation can be used to separate immiscible liquids, but fractional distillation cannot. So just a very quick recap. Immiscible liquid is a very important keyword to represent liquids that do not mix well. For example, classical example would be oil and water. Okay, so oil and water, they do not mix well, so they are what we call immiscible liquid mixture. So simple distillation do not separate immiscible liquid mixture. Fractional distillation is the method that we use to separate immiscible liquid mixture. Sorry, let me rephrase. Okay, sorry. Fractional distillation and simple distillation do not separate immiscible liquid mixture. It is a new technique as a separate technique called separating funnel or using of a separating funnel. Okay, so most of the Sec 1 students, the schools may or may not cover about separating funnel. If you are interested, you can go and Google to see how the apparatus look like. Okay, but A is already wrong. A, we use it to separate soluble solid liquid mixture. Okay, so going to option B, simple distillation uses simple column, but fractional distillation uses fractionating column. So for the second part of the sentence, this is correct. However, for the first part of the sentence, it is incorrect. There is no column involved in simple distillation. In fact, there's no apparatus called the simple column. Okay, so this is just a trick to distract and confuse students. So this is the portion that is incorrect. Moving to option C, simple distillation can be used to separate crude oil, but fractional distillation can. Okay, so simple distillation is true that it is not able to separate crude oil. So if all of you recall, crude oil, or also known as your petroleum, okay, they are what we call miscible liquids mixture. If you understand the keyword from immiscible, you will understand the keyword from miscible. It's the opposite. So if immiscible means do not mix well, then miscible will mean that the liquids mix well. Okay, so likewise, a classical example for liquids that mix well in this separation technique topic would be ethanol and water. Okay, so what method do we use to separate miscible liquids mixture? And the answer is fractional distillation. Okay, so fractional distillation can be used to separate crude oil, but simple distillation cannot. So with that, option C is the correct difference between simple and fractional distillations. Okay, if we do a quick check for option D, both distillation do require boiling chip to reduce the bumping effect by ensuring a smooth boiling. Okay, like what I mentioned, do not worry if you have yet to copy down or annotated everything. Okay, listen, understand, ask question. Okay, this will be more of the effective learning that you will take away from today's webinar. Okay, going to question 2. Please read the question. We want something that is true about chromatography. So chromatography can be used to separate complicated or complex mixtures such as urine and blood. So this is based on your concept. If you study, you understand, you will know that this is true. Okay, so 1 is true. So MCQ technique, if 1 is true, you are very confident that this has to be included in your option, then B and C would be out. So if you are not so certain, not confident, then you do not eliminate any option yet. You continue to check for other option in your in your number 2, number 3, or your number 4. Okay, so for number 2, if we see a single spot on the chromatogram, it suggests that the sample is pure. So take note of this keyword suggest. Suggest does not equals to confirm or is 100% certain. Okay, so this is a concept that you should learn from your chromatography, which is if you only see one spot, it suggests or it may mean that the sample may be pure. Okay, it cannot 100% confirm that the sample is pure. Okay, the reason is because the components in that one spot may all be soluble in that same solvent. So what can we do to check that that one spot is not made up of many different components is that we swap the solvent. Okay, so if we change the solvent, okay, and we realize that now this sample gives me more than one spot, then from that we can confirm that initially in the first chromatography, the sample is not pure. Okay. Okay, so for now, because part 2 didn't say anything that sounds incorrect, we can consider part 2 to be true, okay, or number 2 to be true. If you are unsure, move on. You have 3 and 4. So going to number 3, this technique requires a large amount of sample. This is certainly incorrect. One advantage of chromatography is that it only requires a few tiny drops of the sample. This is the beauty of chromatography, which means you are able to analyze blood. For example, in a crime scene, I believe a lot of you love the detective crime watch kind of crime scene K-drama, right? So in a crime scene, blood we may only be able to obtain small splatters or small drops of blood, and with that small amount, we are able to perform chromatography already. Okay, so number 3 is incorrect. So because it is incorrect and you are confident that number 3 is incorrect, you will be ready to eliminate option A. Okay, so you see MCQ technique, and with strong concept and knowledge, you will be able to pick out the correct answer in no time. Okay. Okay, section B, open-ended, just for filling up the blank from question 3. Okay, so filtration is a blank technique that is used to separate blank soluble liquid mixture, where the solid is collected on the blank paper and is called the blank, and the liquid collected in the flask is called the blank. Okay, so first step, just like English, your English language paper, you read the entire paragraph to get the understanding of which direction, which part of this concept of filtration is the question testing you on. So what is this blank here? It is very clear. Filtration is a separation technique. Technique is very clear. This technique, what is it used for? Is it used to separate? Is it used to purify? Is it used to do some other reaction that will help you? Okay, so this is a separation technique. That's why separation is the only word to fill up this blank. Okay, furthermore, just like English, there will be clues to direct you to the answer in a few blanks. Okay, so filtration is a separation technique that is used to separate blank solid liquid mixture. So I always tell my students, okay, filtration, this method is very easy to pick up. As long as you have a solid in a liquid and your solid does not dissolve in the liquid, your immediate method that you should use to separate is filtration. Okay, so filtration is the only method that you use based on your one separation technique concept. It's the only method that you should pick out to separate insoluble solid in a liquid mixture. Okay, that means the only concept, the only technique you need to apply and learn is which examples are examples of insoluble solid liquid mixture. So sometimes you need to require your general knowledge. For example, if I ask you, can sand dissolve in water? All of you will tell me no. Okay, how do you know? Because since young, maybe you learn a bit of playing a bit of sand and water together. You are learning it through your life experience, gaining them by your general knowledge. Okay, so the next blank would be the solid will be collected on what we call the filter paper. There's no other word except filter. Okay, filter paper is the paper that we use in filtration, and the key word, the general term to represent any solid that is collected on the filter paper is called residue. Okay, same thing, there's no other answer for this blank. So you cannot write insoluble solid, you cannot come up with any word that is close to residue. Residue is the only acceptable answer. Okay, and the liquid that we collect in the flask after filtration, likewise, the only keyword that you learn in school is called filtrate. Okay, so just to do a quick recap on how your typical filtration, a very simple filtration setup will look like. So you can see your filter funnel. Okay, by the way, Sec 1, you learn this in your scientific endeavor, your schematic diagram. Okay, so we generally prefer to use a conical flask to collect the filtrate. And then don't forget to include your filter paper side view. Okay, and your solid will be trapped on the filter paper as what we call the residue, and all liquid will pass through and be collected in the flask. So if we use a conical flask, the liquid will be collected in the conical flask, and the name for all this liquid that we collect will be called filtrate. Okay. Okay, going to part 2. The first blank is empty. Okay, so we just read on. This blank here is a method to obtain salt from seawater. So before you go on, what you should analyze is what type of mixture, what kind of mixture is salt from seawater. Or to be specific, what type of mixture is seawater. The question has already gave you a hint. I want to separate the salt from the seawater, and you should know, and likewise you learn it from your general knowledge, your life experience, that seawater is made up of salt and water. Okay, so you see that salt is a solid and water is a liquid, which means we are looking at a solid liquid mixture. Okay, so students, please learn. Every time when you are dealing with a solid liquid mixture, the next big question you need to ask yourself is, does the solid dissolve in the liquid? Because if it doesn't dissolve, you will perform filtration. If it does dissolve, then you need to think about another separation technique. Okay, so I believe all of you know that salt do dissolve in water. So to be specific, we are looking at a soluble solid in a liquid mixture. Okay, then take note, for you to obtain the solid from the solid liquid mixture, there can only be one method. Okay, so this method here, if you're unsure, we read on and find more clues. So the difference between this method, which is this blank, and another method, so English, is that this method, so take note, this method is referring to the first blank again. Okay, and this method is only used for a certain type of solid and no crystals are formed. But the other method is used for another kind of solid and crystals are obtained. So when you see the word crystal, you can only think of that one method, okay? That one purification technique that is called crystallization. Okay, so this blank here will be your crystallization. So crystallization is the second method and is used for certain type of solid. So likewise, what is the main difference between crystallization and the cousin of this method? Is that crystallization is used when the solid is not thermally stable, which is what we call heat unstable or thermally unstable. Okay, so however you phrase it, since the question didn't limit how many words you can have in one blank, okay, as long as the meaning is the correct science meaning, you'll get the mark. Okay, so you either describe it as thermally unstable or not thermally stable. Okay, so like what I mentioned, what is the cousin of crystallization? Okay, it will be evaporation. So crystallization and evaporation, they are both of the purification technique that you learn in this topic of separation technique. Okay, so if you have managed to identify, then you'll know that the first blank will be evaporation. So some schools just teach it as evaporation, some schools will teach it as evaporation to dryness. Both are accepted. Okay, and between this method and like what we have already identified, the second method called crystallization. So what is the difference is that evaporation is used for the thermally stable solid, whereas crystallization is for thermally unstable solid. Okay, to sum up this entire paragraph, evaporation and crystallization, the similarity is that both of them allows you to obtain the solid from the solid liquid mixture. Okay, so evaporation and crystallization allow us to obtain the soluble solid from the solid liquid mixture. This is the similarity between both of these two purification techniques. Okay, and not forgetting both of them are what we call purification techniques because we remove the liquid. Okay, but the main difference, so I'll only cover the main difference, is that evaporation is for thermally stable solids. For example, your salt. Okay, whereas Your crystallization is the opposite, thermally unstable. Solids. Okay, classical example will be your sugar and your copper 2 sulfate. Okay, whatever the teacher is saying now shouldn't sound foreign to you. All these would be what all schools would cover. Okay, same typical example. Okay, so let me repeat again, students. If you have any question, please post your question in the Q&A. If you did not manage to write down anything that I've annotated, but I've already moved on, it's okay. Listen, understand, and ask questions. Okay, let me go on to the next question. Okay, question 4 is what we call an application question. Why is it considered an application question? Because if you look at this setup is not taught in school. That means you don't learn a technique that is attached to this setup. Okay, if you were to be given this setup in the test, you'll be wondering, hey, what is this setup? Is it a filtration? Is it a distillation, chromatography, or whatnot? Okay, that is why this is an application. You need to apply. What does this setup appear like? What is this setup similar to from the textbook techniques that you have learned? Okay, so very obvious. If you see an ice bag is definitely something cold to cool down a certain other substance. Okay, number 1, that's a clue. Okay, number 2, seawater. So earlier on, we have already covered. Seawater is a soluble, solid, liquid mixture. Okay, and depending on what you want to obtain, so this is a part that I wanted to cover earlier on, but now is a good opportunity for me to mention. If you want to obtain the soluble solid, you perform either evaporation to dryness. Sorry, actually not all. Okay, you only perform evaporation. Oh wait, sorry. Let me rephrase. Okay, you perform evaporation to dryness or crystallization. Okay, because teacher Bell just realized I'm talking about a general solid liquid mixture. Okay, so let me repeat. I apologize if I confused you a little. Soluble solid liquid mixture, if you want to obtain the soluble solid, you either perform evaporation to dryness or you perform crystallization. I will not mention when to do which, okay? We have already covered earlier on. But if you want to obtain the liquid, you only perform simple distillation. Okay, so this is the concept that most students confuse. They learn soluble, solid, liquid, and they learn that evaporation, crystallization, and simple distillation, all these 3 applies to the same type of mixture. But when do you use which? So this is the answer. Okay, so now we need to analyze this question. Seawater, I can either be performing evaporation, crystallization, or simple distillation. So now if we look at the question again, our last clue, we have something called the distillate. So obviously, distillate is the keyword for simple distillation. We don't have the word distillate in evaporation. Likewise, we do not have the word of distillate in crystallization. Okay, so to answer the question, what is this technique? We would have already obtained our 1 mark, simple distillation. Okay, so here comes our explanation. How do I know that it's a simple distillation? If you recall how we discussed, what we have analyzed and allow us to obtain the answer is based on our understanding of seawater. Okay, so here's the explanation. So first we tell the marker, what did we analyze about seawater? What I've obtained as a knowledge or analyzed from seawater is that seawater is a mixture made up of a so this blank would be your keyword of soluble. Okay, why is soluble a keyword? Because if you never write soluble, do you mean that the solid is soluble in water or insoluble in water? Because if it is insoluble, you'll get a different technique already. Okay, so seawater is a mixture made up of soluble solid, which is the salt, and water, which is the liquid. Okay, and based on the diagram, what do we observe is that since a distillate of the liquid, which is our water, is obtained, okay, then what does it show is that this technique must be simple distillation. Okay, as it allows us to obtain the liquid from the soluble solid liquid mixture. Okay, of course, the explanation can be condensed further. Okay, I'm just typing out from what comes to my mind as long as the science concept is correct. Okay, and I always try to type out very simple so that you can understand. Okay, so remember, please do not worry if you have yet to write down all of the answer. Okay, focus on the keywords that I'm emphasizing. Okay, focus on the concept and start to ask questions. Why simple distillation? Can fractional distillation also work? Okay, then post all of these questions in the Q&A, and then I will answer everything at the end of the webinar. Okay, so for now, let me move on. This is a very typical question. Describe how distillate is formed. Okay, so take note, this distillate, you can name it. Okay, but you should know that it is water because distillate is the liquid in this mixture. We already know that seawater is salt and water. That's why the distillate, the liquid, is the water. Okay, so how is this distillate formed? You are supposed to explain all of the important processes that allows us to obtain water from the seawater all the way to the water as the distillate. So if we look at the question, 3 marks. That means 3 important concepts at least. Okay, so where are the 3? This is where you can learn. First would be what is happening in the test tube that we are boiling. Okay, second, what is happening in the delivery tube that is attached to the ice bag. Okay, so what will happen at the third is probably over here as the distillate. Okay, so even if you're unsure with the order, it's okay. Sometimes when we explain our answer, we may start to change the order. Okay, sometimes maybe 2 may be over here, and some students will classify 3 as the ice bag. Okay, so for now, this is the general gist. Let's go and write our answer. So for the first 1 mark will be what is happening in the test tube. So of course, your water is going to gain heat from the Bunsen burner, and it is going to boil off into your water vapor. This is where your first mark is. Okay, by the way, students, reminder, referencing is very important. You do not just say water gains heat and boils off into water vapor. So what is unclear about this answer is, where is your water from? The water in the test or boiling tube. Okay, likewise, secondary 1 scientific endeavor, you would have learned that the test tube we use for boiling would be called boiling tube. Okay, please do not forget from your primary school foundation, water boils off at 100 degrees Celsius. Okay, this 1 mark, most students will be able to obtain. You just need to go and identify where's the start of this distillation process. So second mark will be after my water vapor is obtained, where does it go to? It goes to the ice bag. Okay, so the water vapor travels through the delivery tube. Okay, this tube is called the delivery tube. Then what happens when it comes close to the ice bag? So just like your primary school heat topic, your heat transfer. Okay, the water vapor loses heat to the ice bag. Okay, so what would be these two blanks over here? Same thing, just like your PSLE heat. After it loses heat, is there any process that this water vapor will undergo? So definitely you learn in distillation, in the condenser portion, your vapor will lose heat and will condense, okay, into a liquid. That means you are getting back the water from the water vapor. Okay, so here comes your one last mark, which is what happens to this water. Okay, so this water, you can call it water or your water droplets. Okay, so it will just naturally drip down. Okay, into the test tube and be collected as the distillate. So this last mark here, in fact, is very generous marking as well. Okay, this last mark is just for you to complete your answer. Okay, but it is necessary to show how you obtain water from the seawater all the way to water as the distillate. That is why you must include this paragraph for this last one mark. Okay, so what happens if you do not write this last one mark? You can see that your answer does not stop at anything relevant to distillate. That means your answer is incomplete. So this is one way that you can apply in your checking. You see whether where you stopped at, does it answer back the question? Okay, Teacher Bell will move on to the next question. Okay, this question is a very big question, chromatography. When you go to Sec 3, Sec 4 chemistry, even until your O-level, chromatography and distillation, but more towards chromatography in the upper secondary chemistry. Okay, they always emphasize and come up with a question from ranging from 5 marks to 8 marks, all on the concept of chromatography. So you must master chromatography. Okay, I'm not saying that you don't need to care about other separation technique. You still need to study all of them. Okay, but you must be strong in the concept of chromatography for you to score well in your Sec 3. Okay, so let's go on with the question. So always read the question first to understand the context, the story in our chromatography question. So we have 3 samples, 1, 2, 3. They are separated with this technique, and then I am using these spots from these 3 samples to compare to the spots of 4 other pure substances called PQRS. So do you see that we have 2 different categories of the sample? One category, they are unknown sample. They are what I want to analyze. The second group of samples, they are the samples that I already know their identity. They are what we call the pure samples, PQRS. Okay, so because they are pure, we learned earlier on that there should be 1 spot only. So do you see that P has 1 spot? Or Q unfortunately has 2 spots. Okay, so most likely pure cannot be the correct word already. Okay, then R you have 1 spot, and then S we have 1 spot. Okay, so this is not our concern with the question. We go to the question, name this separation technique. So we already know that this is definitely a chromatography method. So above, if you write the word paper, okay, you will still get the mark. If you did not write the word paper, you will still get the mark because scientifically, this is still a chromatography method. Okay, so going to part B, which sample contains both substances Q and S. So take note of the underlined word, both. Okay, so the sample that you choose, okay, by the way, we are looking at sample. So your answer should either be 1, 2, or 3. 1, 2, or 3. How do I know? Because the question already said the samples are called 1, 2, and 3. Okay, so which among the 3 contains Q and S? Okay, so students, please do not assume. When the question says that the sample must contain Q and S, it is not the same. Okay, contains both Q and S. It is not the same meaning as does not contain P and R. Okay, unless the question include this important keyword, contains only both Q and S. But based on the question in part B, they didn't write this only. That means you cannot pick out the answer that does not have P and R based on this concept. Okay, what you should pick out is the sample that have Q and R regardless of, Q and S regardless of P and R. Okay, so let's go and look at the sample. So my focus will be Q and S. So looking at Q, this is the spot. So using your pencil or your index finger and with the help of your ruler to align, you can see that sample 3 contains the first spot of Q. So earlier on, we already know Q has a second spot, so we need to check whether sample P also contains the second spot of Q. And indeed, it does. Okay, so sample 3 now is confirmed to contain Q. Okay, so if we continue to check for S, likewise, using your index finger or your pencil and the ruler to align and trace, you can see that sample 3 also contains S. Okay, not sample 1, not sample 2, and therefore our answer will be sample 3. Okay, very straightforward, 1 mark. So going to part C, which substance or substances is or are present in sample 2? So now we are picking out the substances, which means that now your answer should be P, Q, R, or S. Okay, so read the question out. I'm finding the substances that are present in sample 2. Okay, so erasing everything, if you have used your pencil to trace out, okay, so that you have a clean chromatography to look at. So looking at sample 2, this is the first spot of sample 2. Then likewise, I trace. Now I'm tracing towards the substance's direction, and I realize that S is present in substance 2. So don't forget to check whether S have any other spots that must also be present in sample 2. So fortunately, S only have 1 spot. That means sample 2 will already consist of S. So there's a second spot of sample 2. Let's check. It is aligned to R. So likewise, let's see, does R have any other spot that I need to check? R only has that 1 spot, and therefore sample 2 consists of both R and S. Okay, so likewise, this question, part C, is a very simple question, R and S. Okay, so the real deal from the question starts from part D. Given that the solvent used was ethanol, what can you infer? What can you tell based on the result of sample 1? And then hence suggest a modification to this experiment. Okay, don't forget your separating principle of chromatography. How do we separate the samples in the technique of chromatography? We separate them based on the difference in solubilities in the same solvent that we use. Okay, so now if I use ethanol given by the question, I notice that the spot of sample 1 remained on the starting line. Okay, it remained on the starting line. So it didn't travel at all. So if the spot of 1 didn't travel at all, what does it tell us about sample 1? It is very clear. Sample 1 is insoluble in ethanol. Okay, so you see, you understand the separation technique. How do we separate all of these components in the sample? It is based on solubility. That means the samples must first be soluble, then there will be a separation. So if 1, there's no separation at all, it stays on the starting line as before, it means that sample 1 is insoluble. Okay, I'll type out answer D over here. Sample 1 is insoluble in, okay. So some students may write, sample 1 is insoluble in the solvent. Please do not write in the solvent. The reason is because the question has already told you that the solvent that I'm using is ethanol. So just be safe, be more specific, use the words and the concept given by the question. Okay, so this first sentence will be the inference asked by the question, and now second one mark, the second part is what is the modification. So modification is what can you modify in the experiment, whether you change a solver, you change your paper, you change the beaker, whatsoever. Okay, what can you change or modify for you to correct this issue or this problem that you have seen? So please do not forget the aim of chromatography. I want to compare the spots of the samples 1, 2, and 3. I want to compare the spots of these 3 samples to the pure substances of P, Q, R, and S. So if of course sample 1 is not separated, I will not be able to do my comparison. So what is this modification here? You change the solvent. But this is the tricky part in your answer. You must mention that you use a different solvent, but this solvent must dissolve your sample 1, 2, and 3. Okay, so this is what teacher Bell mean. So I will write down the wrong answer, then I'll write down the correct answer. So the incorrect answer would be use a different solvent that can dissolve sample 1. Okay, the correct answer would be use a different solvent that can dissolve samples 1, 2, and 3. Okay, because why the first statement is incorrect? Because it is not clear, it is not specific. If you tell the marker, okay, now you use a solvent that can dissolve sample 1, so should sample 2 and 3 dissolve in this new solvent? Yes or no? So obviously the answer must be yes, right? Otherwise you will be facing the same issue, but now with sample 2 and 3 if they are insoluble. That's why be more specific, be clearer. You want to choose a new solvent, a different solvent, but this different solvent must be able to dissolve all of your samples 1, 2, and 3. Okay, if you have any question with chromatography, please type out your answer in the Q&A. Okay, I will move on to part E. If the samples tested were food products, so these samples, don't forget, based on the context, we have already understood samples refers to 1, 2, and 3. Okay, which sample or samples will you recall back from the market? So recall means you take it back. Okay, so when will we take back a certain food products from the market? Okay, it's when we realize that the food products are not safe to be sold, not safe for the consumers to consume. Okay, so that is why using this knowledge that we have as a general knowledge, okay, we answer the question by checking out the chromatogram because this is where our clue, our evidence lie in. So sample 1, we already know it's insoluble, we cannot tell much. Sample 2, okay, 2 spots, we already know that sample 2 consists of R and S. And sample 3, we know that it consists of Q and S. So all these analyses have been made earlier on already. Okay, so among the 3, which is the one that we will recall back, we'll take back from the market? The answer is sample 3. Okay, the reason is because, and in fact, this reason is most of the time the only reason. Okay, so this reason is because if all of you remember, when we were analyzing and aligning or comparing the spots, did you notice that there was one spot that has no identity? That means I do not know whether this spot comes from P, comes from Q, comes from S, or comes from R. We have no idea because this spot does not align to any of the spots in PQRS. So what do we say? This spot is considered an unknown spot. Okay, so to answer part E, okay, let teacher Bell introduce our BlueTree answering technique for explanation question in secondary school. So it is what we call the ICE method. I would be identify your answer. Okay, similar to your primary school, choose a choice or select a choice. The next part of ICE will be C, and C is what we call compare your evidence. You are presented 3 samples. What do? You did a comparison among the 3. That's why you selected one out of all 3 answers. Okay, and the last one is you explain with effect, or you explain its effect. That means you don't just explain your science, you explain and you go on to link it to any effect or outcome that you will obtain. Okay, so first, we already identified our answer as sample 3. Okay, what did Teacher Bell did with all of you for us to select sample 3 as our answer is because we notice that 3 contains an unknown spot. So unknown is a keyword. If you write contains a spot, this is incorrect. Because the spot must be unknown, that's why you will recall sample 3 back. Okay, then here comes the explanation. Okay, by the way, compare evidence, right, is always the evidence you are given by the question. You will always observe this from the question. Okay, so do not throw your science knowledge in the compare evidence. Your science knowledge should come to the under the explanation. So what does this show? Because sample 3 contains an unknown spot, then what does it mean to answer the question? It may mean that sample 3, okay, may be unsafe to consume. Then you see, go on with the effect. So what if it is unsafe to consume? What outcome, what effect can we obtain from here? Okay, which may cause adverse effects like food poisoning. You do not need to go on and say a lot of examples like food poisoning, death, vomiting, whatever. No need. Just give one simple example to illustrate what do you mean by the adverse effect. Okay, so this is a school's favorite question. They love to test all of this concept, relevance to your food, relevance to your medicine, the pharmaceutical industry. So just like food, you do not consume a medicine where the medicine contains an unknown spot, because when you consume it, it may cause you to have stomachache, food poisoning, whatnot. Okay, so with that, this will be your full answer for part E. Okay, going to question F, explain 3 precautions of this separation technique. So this separation technique we have already identified in part A, that is chromatography. Okay, so all of you students will write 2 of them. Okay, the first of them will be draw the starting line with a pencil. This is the popular precaution for chromatography. The second most popular precaution for chromatography would be about the starting line and the solvent level. Okay, so place the starting line above the solvent level. So in case you are wondering what is solvent level refers to the level where the solvent is at in the beaker. Okay, so you can see that this depends on how much of the solvent you pour. If you pour a small volume of the solvent, your level will be lower. If you pour a larger volume, your level will be higher. So this is what we call the solvent level. So remember, in your science learning, chromatography, the solvent level must always be below the starting line. Okay, so for the third precaution, this is usually taught as an optional precaution because it depends from scenario to scenario. Okay, but most of the time, this is what we scientists practice. The third precaution is we place a lid over the beaker. Okay, so let me type out point 4 to explain the key concept as to why each precaution are formed, why they are important in this technique. Okay, so the first point that you must mention about pencil is that pencil contains graphite. And what about graphite? Graphite is insoluble, okay, in most solvents. If you write all solvents, you will not be marked wrong. If you write most, you will not be marked wrong. You will learn about graphite when you go to secondary 3. Okay, so same thing, when you write down the evidence, the information you know about graphite, you do not stop here. You need to answer back to the question. Why graphite is insoluble? Then you use a pencil as a starting line. Because it is insoluble, which means that the starting line does not dissolve in the solvent used, and hence, so keyword, will not interfere with the experimental results. Okay, please do not write affect because affect is very vague. Interfere is the more specific compliant science word. Okay, so to interfere, it means I have an extra spot in my sample, but this spot is not coming from the sample. This spot came from my starting line. So that's what we call interference. Okay, going to number 2, what is the second precaution, the explanation? So the reason why we place the starting line above the solvent, okay, is do not forget that your starting line contains the sample already. And also recall that your samples, they are all supposed to be soluble in the solvent that you use. So why do we place the starting line above the solvent level? As the starting line contains the sample which are soluble in the solvent. Okay, this prevents, so this refers to by placing the starting line above the solvent level. Okay, so this prevents the sample from dissolving into the solvent before separation begins. Okay, so likewise, continue to explain what is the outcome over here, what is the effect. Okay, so when we have our sample dissolving into the solvent before the separation, what is the consequence that we will get is that all the samples will go into the solvent. We will not have any more samples on the starting line, which means obviously you will not be able to observe any results. Because your samples are no longer on the chromatogram, they have all went into the sample. Sorry, all went into the solvent. Okay, so in other words, to put it simple, you do not have any more sample on the paper. That's why you will not see any spots. Okay, so to end off, otherwise, no spots can be observed on the chromatogram. Okay, let me focus more on precaution 3 because like what I mentioned, it depends on your school whether they mention or taught you about precaution number 3. Okay, place a lid over the beaker. So most of the time, we have 2 reasons why we place a lid over the beaker where your beaker contains your chromatography. So it contains your chromatogram where you are allowing your chromatography to take place. Okay, so the first reason is when we use what we call a volatile solvent. Okay, volatile, it shouldn't be a new word. Okay, volatile means easy to evaporate. For example, alcohol. That's why your hand sanitizer evaporates very quickly because it contains ethanol. So when a volatile solvent is used, a lid prevents the volatile solvent from evaporating. Okay, if you write slows down, acceptable as well. Okay, then you may wonder, then teacher, why do we not want the solvent to evaporate? Don't forget, the solvent is there to allow your chromatogram to absorb. If you do not have enough solvent, the chromatogram cannot absorb enough solvent, then therefore your separation will stop. Once your separation stops early or prematurely, you will not be able to obtain an accurate separation results. Okay, so the second possible explanation why we place a lid over is to prevent contamination. Okay, between the surrounding and the experiment or the chromatograph. So contamination can come in many forms. Okay, for example, contamination where you accidentally spill a few drops of a substance into the solvent. Okay, then it may cause, it will definitely affect the reliability of your experiment results. Okay, so just to summarize, focus on 1 and 2. Okay, precautions 1 and 2 definitely, certainly tested. Okay, so likewise, you go to Sec 3, Sec 4, these two precautions are always there as an exam question. Okay, let's go to question 6. Question 6 will be considered the toughest question in separation technique. Okay, that is why I included this in our webinar. Question 6 is the question that most students will struggle to start, struggle to obtain the full marks that the question is giving you. So a question like this typically will be around 4 to 6 marks, 4 marks at least. Okay, and likewise, this question will also be seen in your upper secondary chemistry, in your separation technique. Okay, so there's technique or skills to score for this question, and that is why Teacher Bell will teach you in this webinar. Okay, so first, let's read the question. We need to outline every step, and what is our objective is we need to separate a mixture of X, Y, Z to obtain dry and clean sample. And take note, we are looking at individual substance, which means in my beaker, I have all three X, Y, Z mixed together. I want you to extract out X only, Y only, Z only. That means I want you to separate X, Y, Z, and all of these three substances must be dry and clean. Okay, so here is the technique. Let's go on with the question. So if you analyze this table, they give you a lot of properties. Whether it can attract to magnet, whether it can dissolve in ethanol, does it decompose upon strong heating, melting, boiling point also given. So students, please take note, not all information given by the question are all necessary in your answer. Some of them may be added as an extra information as a distractor. Okay, so let's start. Imagine you have a beaker of X, Y, Z mixed together. You always target the property that is allowing you to obtain the odd one out solid. So what I mean is, if we look at the attraction to magnet, do you see that there's already an odd one out? Sample Z is magnetic, but Y and Z, they are not magnetic, which means I can perform a certain separation technique and I will already get X on its own. Okay, if you are able to obtain X on its own, you will have gotten 1 to 2 marks already. Okay, so here comes the answering. How do you write down your answer? Follow this format: verb, object, outcome, and plus keywords. Okay, so almost all schools, the marking scheme from the teachers, they follow such structure. Of course, structure can be flexible. You can sometimes your structure can arrange itself depending on the English that you need to phrase. But this is the general rule of thumb. First, you write the verb. What do you do with this verb? Which object are you dealing with? And then what is your objective? What is the outcome that you're trying to obtain? So the keywords, it's optional. Some techniques require certain keywords. Some techniques do not. Okay, so first step, we already know I need to perform a technique called magnetic attraction. So what do I use? I use a magnet. So you see the verb, I use a magnet. Okay, so use a magnet. Then what do you use the magnet on? What is your object here? Use the magnet. And then what are you trying to obtain? Okay, what I'm trying to get is I'm trying to attract X from the mixture of X, Y, Z. So you see your verb, use a magnet. Then this time round, we write the object at the end because of the English phrasing. Okay, and what is our outcome here? I'm trying to attract X. So the keyword for this statement will be attract. You don't write to get, or you don't write to obtain. Okay, you do not write get, you do not write obtain, you write the keyword attract, because magnetic attraction, attract is the keyword. Okay, so do you see that in under step 1, we have already gotten sample X? And all these are solid individually, so sample X is already dry and clean. So now we are ready to go on, okay, to look at the remaining mixture. So don't forget to also talk about the remaining. Okay, so to attract X from the mixture of Y and Z, leaving behind the mixture of Y and Z. So when you write the substances that is left behind, it helps you to flow or connect to the next step. So now our mixture is containing only Y and Z. So what do I do? Attraction is not going to work because Y and Z, they are both non-magnetic. So we go on to the next clue. Can it dissolve in ethanol? Do you see that there's a difference already? Y can dissolve in ethanol, but X cannot. So this is where you are going to leverage this difference on. So what you do is you add ethanol into where? What is your object? Into the mixture of Y and Z. And then what is your outcome? What are you trying to obtain? Okay, when I add ethanol into the mixture of Y and Z, I know that Y will dissolve. So to dissolve Y and not Z. Okay, so when you add ethanol into the mixture of Y and Z, only Y will dissolve and not Z. Then don't forget, write your final mixture. What kind of final mixture will you have after you dissolve Y and you don't dissolve Z? If you notice, this is what we call an insoluble solid Z in a liquid or in a solution or liquid of Y. Okay, so when you manage to identify the type of mixture, remember earlier on, Teacher Bell mentioned, every time you have an insoluble solid in a liquid mixture, the next step to do this separation is only this method called filtration. Okay, so what is the what is the verb for the keyword from filtration? So most students, they do not know, so take away from this webinar. The verb for filtration is what we call filter. So your verb, you filter. Then what are you filtering? What is your object here? You are filtering the mixture of Y and Z. Then what are you trying to obtain? What is your outcome? To obtain. So remember, the insoluble solid Z will be collected on the filter paper, which is what we have covered earlier on. And here comes the keyword for filtration. When we collect the solid on the filter paper, the name for this kind of solid will be what we call residue. So you filter the mixture of Y and Z to obtain solid Z on the filter paper as the residue, and your liquid Y. Okay, so you can write conical flask, you can write beaker. Okay, up to you. Conical flask beaker will be what we call the collection flask. Okay, the flask that we put at the end underneath the filter funnel to collect the liquid. Okay, and then here comes the last keyword. The liquid that you collect will be called filtrate. Okay, so do you see initially we have X, Y, Z mixed together? I do magnetic attraction, I get X. So Y and Z, this mixture, I add ethanol, I perform filtration. Now I have already separated Y and Z. So let's deal with the easier substance. Currently, Z is the easier one because Z is already as a solid. But what do we do to make sure it is dry and clean? We wash solid Z with distilled water. So take note, do not write tap water. Do not write water as well, write distilled water. Okay, and then how do we dry it? We dry the clean solid Z with filter paper. Okay, so students, please take note, you only dry solids with filter paper. You do not dry with tissue paper, with your towel paper, and needless to say, with your clothes. Okay, you only dry it with filter paper. Okay, so last few steps before we are done for this 6-mark question. Okay, so just to refresh, we now already have solid X. We already dry and clean solid X from step number 1. Step number 4, we already obtained our dry and clean solid Z. Now we are left to deal with liquid Y. So Y is a liquid. I want to get back the solid. How do we know? Because question already said dry and clean. The state that we are looking at has to be dry and clean for solid. You cannot have dry and clean for liquid. Okay, so this is where the next clue comes in. For liquid Y, it will decompose upon strong heating. Okay, so remember, when I want to convert liquid Y to a solid Y, I'm trying to remove the liquid, which is removing our solvent here, which is ethanol. So when I want to remove ethanol, I'm trying to do a purification technique, either evaporation or crystallization. Okay, so this one Teacher Bell earlier on covered already. So because they gave us that Y will decompose upon strong heating, that is why we do crystallization. Crystallization, very important. Okay, crystallization, to recap, there are 2 steps. One is the heating, second is the cooling. Okay, so I will just share with you the important keywords. The first step for crystallization is you heat. So what do you heat? You heat liquid Y. What are you trying to do? What are you trying to obtain? What is your objective or your outcome here? Okay, we are trying to evaporate. So this is the keyword, most of the ethanol. So take note, now it's not water, now it's ethanol. Because the solvent that I used to dissolve Y was not water, it is ethanol. Okay, so heat liquid Y to evaporate most of the solvent. Then the next keyword, to obtain a saturated liquid Y. Okay, so this is step number 5. So at the end of step number 5, we do not have the crystals of Y yet. Please take note, crystallization, earlier on Teacher Bell already mentioned 2 steps. You heat and then you cool. Only during the cooling step will you obtain crystals. So what is the verb? You cool. What are you cooling? Cool the saturated liquid Y to room temperature. Then what are you trying to obtain? What's your outcome? To obtain crystals of Y. So the keyword for this question would be crystals. Sorry, for this statement will be crystals. And then last step, what do we need to do to ensure the crystals are dry and clean? You do the same as step number 4. Wash the crystals of Y with, but this is the difference between this washing step after crystallization and the washing step in step number 4 is that crystallization, we need to use cold distilled water. Okay, so wash the crystals of Y with cold distilled water and dry them with filter paper. So the end. This would be the 7 steps with all of these necessary keywords following the general answering structure of verb, object, outcome plus keywords for you to obtain the full 6 marks. Okay, so I'll leave this page over here. I'll give everyone a few seconds to look through, to understand your own annotation. Okay, and then I will answer the Q&A that we have. Okay, so I will start the Q&A answering at 8:10. Please use this time to look through. If you have any question, you would like to revisit another question in this webinar worksheet, please let me know. Okay, so first question coming from Anne. Okay, what is the difference between fractional distillation and simple distillation? So this, I suppose, should be the first question from MCQ. Okay, or maybe from the open-ended in the simple and fractional. So there are many differences. The first difference is what do we use this technique for? Simple distillation is used to separate soluble solid in a liquid mixture. That means your solid must dissolve in the liquid that you use. And with this mixture, I can perform simple distillation. Okay, but the more important takeaway from this statement, this concept, is simple distillation allows you to get the liquid from this soluble solid liquid mixture. Okay, whereas for fractional distillation, it is the method that we use to separate miscible liquids, like over here. Okay, fractional distillation is used to separate miscible liquids. So miscible means the liquid mix well with each other. For example, ethanol and water. Okay, so this is one main difference. Another second difference would be based on the setup. Fractional distillation uses an extra apparatus called the fractionating column, but simple distillation don't have this column. Okay, there is no fractionating column. It is the rest of the apparatus except this fractionating column. Okay, so the first difference, the type of mixture that we use for each of the separation technique. The second difference will be the additional apparatus required for fractional distillation. Okay, so and I hope this answers your question. Okay, so Frelin asked, can we write desalination instead of evaporation? So desalination instead of evaporation, okay, over here. Okay, so for number 2, based on this statement over here, this blank is a method to obtain salt from seawater. Because of this keyword called method, you cannot write desalination. Okay, so some students, they will confuse, what is the difference between desalination and evaporation? So evaporation is the method, is the technique that we perform in laboratory to allow us to obtain the soluble solid from the solid liquid mixture. But desalination is the application where we apply this technique to the real world for us to obtain salt from seawater. So friend, to help you to understand further, if they change the word here, this blank is an application. Okay, if they add in, okay, sorry, let me change the font. Sorry, change the color. Okay, let me do a bit of erasing. Okay, so really, if the question mentioned, this blank is an application of a method to obtain blah, 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 to obtain salt from seawater, then you write desalination can be accepted. Okay, so do not write deionized water when it comes to washing. Okay, I'm not sure, maybe your school, Freddie, you learn deionized water from your school. Okay, but then 99% of the schools, right, MOE schools, whatever school, we all learn through distilled water. The reason is because now you are only secondary, you do not need to know any kind of special laboratory water besides distilled water. Okay, so just play safe, just follow distilled water. Okay, so Kayla asked a very good question. Okay, teacher will purposely never explain this to see whether any of you will ask this question. Okay, why do we wash the crystals with cold distilled water, but why did we not wash the solid Z with cold distilled water? Okay, this one is your solubility. Okay, so don't forget your concept of solubility in your elements, compound, mixture. So all schools would be at this topic already, elements, compounds, and mixture. So under the concept of solubility, you learn that the higher the temperature, the more soluble the solute is in the solvent. Okay, your crystals are solid. If you use a hot distilled water or even maybe a room temperature distilled water, your crystals may start to dissolve in this warm water. That means while you wash your crystals are dissolving and escaping out of your filter paper. So what do you get at the end? A few crystals only. You don't get much of the crystals. Okay, so that is why cold distilled water. Okay, so Jenny also asked a very good question. How do we separate two liquids or solids? Okay, so if you have two solids, you need to check if one of them is magnetic. Because Jenny, if one of them is magnetic, you immediately perform what we call the magnetic attraction. To attract the magnetic solid, leave behind the non-magnetic solid. Okay, so if your solid, all of them or both of them are non-magnetic, not able to be attracted, then you check on solubility. That means one solid must dissolve in the solvent that you use, but not the other. Okay, that is why over here we performed this solubility technique. So Jenny, do you see that Y and Z, both of them are non-magnetic, but one of them is soluble in ethanol, the other is not. That is why for me to separate these two solids of Y and Z, I will be relying on this concept of solubility. So when I add ethanol, one of them dissolve and not the other, the next immediate step, you just perform filtration. Okay, so to answer the next question that Jenny have asked or posed will be, what happens if you have two liquids instead? Two liquids in a mixture. So same thing, two liquids in a mixture, you ask yourself, can the liquids mix well with each other or not? Because if the liquids, they mix well, like ethanol and water, which is what we call miscible liquids mixture, you perform fractional distillation to separate the miscible liquids. Okay, so for the opposite scenario, which is what Teacher Bell mentioned earlier on as well, if your liquids do not mix well, for example, oil and water, what do is you use a technique called using a separating funnel. So a separating funnel is just like a container or a funnel that has a tap at the bottom. When you open the tap, the liquid at the bottom layer will drain out. When you only have the top liquid left in the funnel, you immediately close the tap. Okay, so if you are interested, feel free to go and watch YouTube to go and read up more on this technique. Okay, so Jenny, same thing. I hope that I've answered your question. So going to Crystal Bell, is distilled water the same as mineral water? Not the same as mineral water. Okay, your mineral water, okay, distilled water, a lot of students will question, can it be drank by us humans? Okay, of course, it is still a clean water, it's still a consumable water, but then you do not drink anything you see in the laboratory. So please do not attempt. Okay, students, please do not attempt. Okay, so distilled water is not exactly the same as mineral water. Likewise, deionized water may not be the same as your distilled and mineral water. Okay, so same thing, if you are interested, feel free to go and do your research. This is not covered in the syllabus. Okay, so next, and ask, how do you heat up a substance that is flammable? Okay, so if the substance is flammable, you cannot do direct heating. Very good question, and because sometimes your distillation will appear this concept. So it will require you to have this concept. Okay, so I know Teacher Bell is exceeding the webinar, but all these are interesting questions, and for questions that are often frequently tested in your syllabus, I will explain a bit more. Okay, so please continue to stay on with the webinar for you to learn and gain all of this extra information from all of this Q&A that I'm receiving. Okay, so I'm only drawing part of the setup. This is going to be your, this is supposed to be your simple distillation. Okay, so pardon my drawing not very accurate. Okay, because I don't have the time to draw it very accurately. Okay, but I know all of you know the correct diagram. So let me just focus on the question. How do you heat up a substance that is flammable? So the one rule is that if your substance is flammable, you do not perform direct heating. No direct heating. So no direct heating means you do not put the fire directly above or below the flammable substance. So what do we need? We need a middleman. Your middleman can be either water oil, or sand. So this is what we call water bath, oil bath, or sand bath. Okay, so water bath, oil bath, or sand bath will be the middleman that we use. So what we are actually heating is we are heating this water, this oil, or this sand. So when this water, oil, sand gets heated up, of course, it will get hot eventually. That's why this heat from this water, oil, or sand will now slowly and gently travel to your flammable substance. That is why your flammable substance will not receive the heat too much at once, so it will not catch fire. Okay? Okay, to the last question, likewise from Anne, what is sublimation? Okay, sublimation is very important. Sublimation is a process where the solid gains heat and changes directly, keyword, into a gas. Okay, so sublimation is a process just like your melting, boiling, whatsoever. Okay, it is a process of change of state. But this difference is that the solid will change directly into a gas, to be more specific, without becoming a liquid. So in case you're wondering, what substances are so special that can sublime without melting first? Your dry ice. Dry ice is your solid carbon dioxide. Don't write gas because you're contradicting. Okay, solid carbon dioxide. So if you take out your dry ice, you'll notice that your dry ice will vaporize immediately, giving you the very mystical effect. Some of us use dry ice in our wedding to give the mystical effect, the very fairy tale, okay, vibes in our wedding. Or magician, they also use dry ice. Okay, so this is an example of a substance that can sublime. Another chemical substance will be your iodine. Okay, feel free, go and watch YouTube, go and Google sublimation of iodine. You can see all of the sublimation experiment for iodine. Okay, it will serve you as a very good visual help in your learning. Okay, so for those questions, I hope that I've answered everything.